Assalamu alaikum and good afternoon, everyone. In our last lecture, we have learned about reinforcement learning and one of the technique typically used in reinforcement learning called Q learning. So today, we are going to have a look at one of the example for Q learning applications to solve manufacturing problem. So let's have a look at one of the journal paper published in 2011 entitled A Q-Learning-Based Adaptive Grouping Policy for Condition-Based Maintenance of a Flow Line Manufacturing System. So basically the paper would like to solve the maintenance issue for a flow line manufacturing system. And if we look at in the abstract, they are using condition-based maintenance or CBM, where the maintenance action are carried out as warranted by the condition of machines, and this will reduce the risk of having reactive maintenance, where when we have reactive maintenance, normally we will have to shut down certain production system. So in order to avoid the unpredictable breakdown of machines, we can use condition-based maintenance for us to ensure that all of the machines are maintained accordingly. So in this paper, they would like to find the optimal grouping policy for the CBM. See, when we want to have a condition-based maintenance, we need to group the machines that need to be maintained, so that whenever we want to do a maintenance process, the machines can be maintained based on the respective conditions. They will be served in batches, first batch, second batch, third batch, and so on. So here they use the Q-learning algorithm to come up with the grouping policy that will reduce the setup cost and increase the uptime efficiency of the flow line manufacturing system. So this is normal, especially when we are dealing with optimization problems. So we can see here they put up two objectives. The first one is to reduce the setup cost for maintenance, and the second one is to increase the uptime efficiency. And typically when we deal with optimization problem, we are going to use contradictive objectives. So here the setup cost and uptime efficiency is are two objectives that belongs to different groups. Okay, the breakdown of even a single machine in a flow line system could affect the availability of the entire system, particularly when there are no storage buffer in between successive machines. So the results reported here show that proposed Q-learning based grouping policy is capable of reducing the number of repair and maintenance interruption considerably. So whenever we want to use the reinforcement learning to solve a manufacturing problem, there are certain elements that need to be taken into account. We need to set up certain elements. Okay, as in many other journal system. So this paper starts with introduction, and the introduction states about the growth of the maintenance issues. So previously they used certain other concepts, and this is the summary for the maintenance approach or maintenance technology. The first one is no maintenance. So this is totally bad. And then some of the factories they use reactive maintenance, where they only repair machines that are broken down, which is not really good because it affects the uptime efficiency. The third one is preventive or periodic maintenance. This kind of maintenance are normally preset. So for example, this machine will be maintained annually, and this machine will be maintained after several hundreds hours of operating time, and so on. The fourth one is predictive or condition-based maintenance. So when we have predictive and condition-based maintenance, we start to use the sensors in order to measure or in order to identify the conditions of the machines. So those machines will have the ability to inform the technician, the staff, that okay, these parts need to be maintained, these parts need to be maintained, and so on. And finally, we will have a proactive maintenance where advanced algorithm will be used in order to set or in order to cater the problem before the problem could take place. Okay, and they have the introduction on CBM as well. CBM integrates the concept of machine condition monitoring, intelligent condition-based fault diagnosis and prediction of component deterioration trend, typically available to mechanical components whose conditions deteriorates with time. So what are the components? We are looking to look at the components of reinforcement learning to solve CBM issues.